So in our last unit, we talked a lot about temperature. We were studying heat transfer, and we looked at examples like the one you see on the slide, somebody holding something hot to show that heat can transfer from objects that are hotter to objects that are less hot, right? So that is a rule about heat transfer, is that when two objects are touching, heat will naturally transfer from the hotter object to the colder one. That could be what happens when you touch a hot object and it burns your skin, but it's also the reason why objects sometimes feel cold. For example, if you put a bag of ice on your arm, it's not a substance that is cold that is transferring to your skin, but when you put a cold object in touch with a hotter object like your arm, that means that naturally the heat is going to start to transfer from your arm to the ice, and that is going to make you feel colder. The reason we're reviewing temperature is because there's a similar process that happens with pressure. Differences in pressure also affect what we see in nature or what occurs naturally. When two fluids, which could be liquids or gases, are in contact, the fluid that is higher pressure will naturally move to areas of lower pressure. So if you look at the whitewater rafting example in the corner, what happens in a river is that areas that the water is moving more quickly, so this area of the rapids, would be considered lower pressure. The wider, slower moving part of the river is technically higher pressure. And that might not make sense at first, but I promise that it's true. Areas of higher velocity have lower pressure than areas of slower velocities. So as the water changes speed, that creates a low pressure area here. And what happens is it draws in the fluid from the high pressure area. So that's why it might feel like the boat is getting sucked into that area because of the low pressure area. Another example is what happens when you're breathing. So when you're breathing, you have a muscle called your diaphragm that lowers and that expands the space in your chest. It creates a larger container in your chest cavity. And we might think that breathing it requires a lot of effort, but it actually is a natural process that has to do with the air pressure outside of your body and inside your body. You're a fluid system. When your diaphragm drops and the chest cavity expands, that creates a larger container. And because the container is larger but still has the same number of particles, that lowers the pressure. So the same way making a smaller container can increase the pressure, making a larger container with the same number of particles would decrease the pressure. Sometimes that's described as a vacuum. So what happens when your chest cavity expands is that it creates a vacuum or a low pressure area so that air naturally goes into your lungs, fills them with new air, right? Your body exchanges those gases. And then when your diaphragm relaxes, that creates a higher pressure area. And that means that naturally some of the gas will want to escape, which explains why you can breathe even when you're not thinking about it, and that breathing happens very naturally even when you're asleep, right? Because your diaphragm is just creating a larger container and then a smaller container, a larger container, and then a smaller container for you. So the air will naturally move in and out of your chest cavity. One more example is what happens with weather patterns, which I am not a weather expert, but I found this example and I thought it was interesting. If you look sometimes at a weather map, they will label the low and high pressure areas of the map. And the same way that the low pressure areas of a river will draw in the high pressure fluids and any objects that are traveling in its path, the same thing happens with our atmosphere. So the low pressure areas on the map will draw in the weather from the higher pressure areas. So that's one way they're able to track or predict where weather is going to travel or move, is based on the low and high pressure areas of the map, because fluids will naturally move from areas of high pressure to areas of low pressure.